Question number 18. So we have in this diagram A, B, C, and D and E lie on the circle. So A, B, C, D, E. Great. So we have AB is parallel to ED. So AB is in the same direction as ED. Angle ABE, so ABE is 62. Angle CDE is 127. Angle BEC is 40. Okay. So question part 1, find the angle x. So how do you find the angle x? Angle x is this one. And you can use the property of the complementary angles. As you can see, let's take this out. Let's take the shape out. We can have a better look. So we have B here, C here, D here, E here, and we join them. So this is B, C, D, E. We know this angle is 127, and we're looking for this angle, which is angle X. So as you can see, all the sides B, C, D, E touches the circumference, so we can use this rule. It is a quadrilateral, so the opposite angles, the sum is 180. So x plus 127 is 180. So x will be 180 minus 127, which will give you 3, 5. So x is 53 degrees. Okay, so now part y. Find the angle y. Part B, find the angle y. So angle y is here. So as we can see, angle y reflects on the same arc BC as 40 on the same arc. So we use the rule. Angle that is basically angles from the same arc AB, sorry, this one is BC, so the arc is BC, are same, are equal. So thus, angle y equal to angle 40. So y is equal to 40 degrees. Okay, so now part C, find the angle Z. Where is Z? Z will be this angle. So we have to observe actually, because we have to use the information that we're given, which is AB is parallel to ED. So let's have a look. This is AB and this is ED. So that's the line that joins them. So these two are parallel. So there's one rule. It says that if the line are parallel and if they are joined by a diagonal, this angle will be equal to this angle. So this angle here is what? Is 62. And this angle here is what? It is, we have 40 plus Z. So what is the value of Z? So it will be, these two are equal, so 40 plus Z equal to 62. So Z equal to 62 minus 40, that will be 22. So your answer for part C will be 22. Okay, that was it for question number 18. Now moving on to question number 19. It's a locus of points. Let's just get some more space so we can draw using a compass. So in the diagram, PQ, which is this line, intersects LM at point O. Okay, so question number 1. On the diagram, construct part A, the locus of points that are equidistant from the lines PQ and LM. As you can see, there's no common points in those two lines, so PQ, LM, but they intersect at point O, which means we have to draw two lines on this section. So one will be in this direction, which are equidistant from the two lines, and one will be in this direction that will be equidistant from those two lines as well. So two lines will be representing the answer for part A. So let's do that. So we have to use our compass, and so let's begin with this. So we first have to cut this two line at those 2 points, and then go on those 2 points, draw another arc inside, and on this line as well, the same thing. You will see there will be a point of intersection. So now we just have to join this point of intersection with a point O to form the first part of the line, which is equidistant from those two lines. So that's the first part. Right. Now, because we have this angle and also this side, we have to draw another line which is equidistant from those two lines. So this one will be the same step. We have to go to point O and then intersect those two lines. So at P and M, go to the point of intersection, then draw another arc, and same thing here as well. Oh, it's not intersecting. No, I watched it here. I made a mistake maybe. No. This point, okay, it's good. So we go on this point and has to intersect. Okay, so here we have a point of intersection. So we have to join this to the line O to form the locus of point, which are equidistant from the two lines. So that's answer for part A. So these are the two lines that are equidistant from the lines PQ and ML. Okay. So now we have to do number B. Find the locus of points that are equidistant from O and Q. So point O is here, point Q is here. We have to draw the bisector of OQ. Yes, you go to point O, you draw an arc up, arc down, and you go to point O, intersect the two arcs, so on top and at the bottom. So you have two lines of intersection, the point here and the point here. We just have to join them to form the bisector of OQ. Okay, so that will be your answer for part B. This is your answer for part A and A. Okay, that was number 19. Now moving on to number 20. 20 is the points. So P is a point -3,4, Q is a point 5,1. Find M. M is the midpoint of PQ. So we have to use a formula. M is, the midpoint is -3 plus 5 divided by 2, and 4 plus 1 divided by 2, which is equal to -3 plus 5 is 2, divided by 2 is 1, and 5 over 2. This is your answer for the M, which is 1, 5 over 2. So now part B, find the gradient of PQ. The point P is -3, 4. The point Q is 5, 1. Label the point. This is x1, y1, y2, x2. The gradient is equal to y2 minus y1 over x2 minus x1. So y2 is 1 minus 4 divided by 5 minus 3, which is -3 over 8. That is your answer for the gradient. So now question number C. R is a point 0,6, O is a point 0,0. Which points R or P is closer to A? So we have to find the distance of OP and OR. So know that P is what point? P is the point 3, 4. So distance, we have to use the formula, square root of, so we have to do x2 minus x1, which is -3 squared, plus 4 minus 0 is 4 squared, which is equal to 25, and the length of OP is 5. So same thing for OR. R is a point -60, so -6 minus 0 is -6 square, and then 0, 0, 0, so same, so that will be 36, will be 6. So which one is closer to O? The points P, because the distance is only 5 compared to 6 with OR. So the distance closer to, the point closer to O will be point P. Moving on to question number 21. So 21, we have evaluate 9 power 1 plus 9 power 0. So 9 power 1 is 9. 9 power 0 is 1. So the answer will be 10. Find n where 4n equal to 2n minus 1. So 4 is also 2 power 2n equal to 2n minus 1. So since the base are equal, we can just write this down. So this will become, if we send n on this side, will be 2n minus n equal to minus 1, n equal to minus 1. That will be your answer for part B. Now moving on to question number 22. The universal set is 0, 1, 2, 3, 4, 5, 6. Now we have P is the set of 0, 1, 2. Q is the set of 0, 2. List the members of P and Q. So everything which is common in those two sets. So we see 2 and 0 are common. So the set is 0 and 2. So now part B, find the number of elements in this set. What is P dash? Everything which is not in P, which is 3, 4, 5, 6. What is Q? Q is 0, 2. Thus, we have P union Q equal to 0, 2, 3, 4, 5, 6. So now the answer is find the number. So we have 1, 2, 3, 4, 5, 6. So the number will be 6. So for part C, the set R is equal to 2x plus y, where x is in P. So P is this set, 0, 1, 2. And R is a set, Q is a set. Q is 0, 2. Okay, so R is defined as Z equal to 2x plus y. X come from P, y come from Q. So there's 3 possible cases. Case 1, where P equal to 0. So what can be R? R will be, which is Z equal to 2, 0 plus y can be 0. That's the first option, which will become 0. Or it can be 2, 0 plus 2. That's the case 1. Now case 2, we can have P equal to 1. So Z equal to 2, 1 plus 0 will be 2. Or it can be 2, 1 plus 2 can be 4. And now the last case, we have case 3, P equal to 2. So Z equal to 2 power 2 plus 0 will be 4. And 2, not power, but times 2. So next case will be plus 2, which will be 6. So all these elements can be in R. So R can be 0, 2, 2, 4, 4, 6. But since you see we have repetition, we have to cancel out 2 and 4. So the set R is 0, 2, 4, 6. And this will be your answer for part C. Question number 23. That was 21, 22, 23 is here. Okay. So we have vectors. Express this vector as a single vector. So first step, we have to bring the 3 inside. So 3 minus 1 is minus 3. 3 times 2 will be 6. The first one is 3 times minus 1 will be minus 3. And then 6 plus, bring the 2 inside. 0 times 2 is 0. 0 times minus 2 is minus 4. Okay. So 2 minus 3 will be 5. So 5 plus 0 is 5. So 1 minus 6 is minus 5. Minus 5 minus 4 is minus 9. So that is your answer for part A. Now question B, we have to multiply. So 2 minus 1 0, 3, minus 1, 1, 2, minus 3. So we always have to multiply rows by column. So let's first look at the first column. So rows will be what? 2 times 10. So 2 times 0, 2 times 0 plus minus 1 times 3. That's the first column done. Now look at this one. 2 times minus 1. So 2 times minus 1 plus minus 1 times 1, minus 1 times 1. Not done. The last one, we have 2 times 2 plus minus 1 times minus 3. So your answer is what? 0 minus 3 minus 2 minus 1, 4 plus 3. So your answer will be minus 3, and 7. That is your answer for this part B. Okay, question number 24. So a train travels from 2 stations starting and finishing at rest. So rest will be at the x-axis. Okay, so for this journey, it accelerates uniformly from rest. So from rest will be from the point 0, 0 for the first 30 seconds until it reaches the speed of 20 m per second. So for the first 30 seconds, it accelerates uniformly and reaches the speed of 20. So 30, 20. Since the acceleration was uniform, we have to join them with a straight line. Okay, so the next part is it travels at this constant speed for the next 60 seconds. So next 60 seconds will be 30 plus 60 will be 90. Okay, so it will continues as at the same speed until time is 90. So at this point it stops here. Okay, and the last one, it slows down uniformly for the last 20 seconds until it stops. So 20 seconds, 90 plus 20 will be 110, so it stops here. So the graph is, this will be the graph representing the journey of the train. So this one, just take it out. It's not in the drawing, so it's not good. So that will be trapezium area. So for part B, calculate the distance between the 2 stations. So whenever you have a speed time graph, the distance traveled is the area on the graph. So as you can see, this is a trapezium shape. So this distance down will be 110. And this distance up will be 90 minus 30 will be 60. And the height between the distance will be 20. So area of trapezium is what? It's half times distance, sum of 2 sides, which will be 110 plus 60 times distance in between, which is 20. Now we simplify, so 2 with 10, that will be 170 times 10, which is 1,700 meters for the distance traveled between the 2 stations. Now moving on to the last question, question number 25. So in the diagram, we have ADB, so ADB, and ACF are straight lines. Okay, so we have BC intersects DF, so BC intersects DF at point E. Okay, we have AC, ratio CF is 2 to 1, so this is 2, this is 1 in terms of ratio. So we are given this information about the length of each points to the other points. Okay, so part A, express AB in terms of P. So AB. So how can you move to AB? So AB, according to the diagram, we have A can move to C and C can move to B. So AB equal to AC plus CB, which is equal to A moving to C will be 3P plus 5Q. And then if it moved from C to B, it will be minus 2 because 2 Q is in this direction. If we go to this direction, it will be minus 2Q minus 3Q. So which is 5Q, so minus, the answer will be 3P. So AB is 3P. So now part B, express CF in terms of P and OQ. CF is this distance, so we have to use the ratio given to us. So we know that AC is the ratio of 2 to 1. We need to find CF. So let's express that in terms of fraction. So AC over CF equal to 2 to 1, right? Find CF. So CF will be, so we cross multiply, and then it will be AC divided by 2. So AC is 3P plus 5Q divided by 2. So your answer will be, let's do half outside and then 3P plus 5Q. That will be the answer for part B. Okay, now for the part C, EF. Express EF in terms of POQ. So where is EF? EF is this point. EF equal to EC plus CF. EF is EC plus CF. EC is 2Q. CF is 1 half 3P plus 5Q. Simplify, we will have 3 over 2P plus, so we have to do 2Q plus 5 over 2Q. That will be 4.5. So 4.5 will be 9 over 2Q. So answer will be 3 over 2P plus 9 over 2Q for this section. So now for question D, we have EF is K times DE. So we know EF equal to this. So let's say EF equal to 3 over 2P plus 9 over 2Q. Let's take 2 out. We will have 1, 2, which is 3P plus 9Q. So we observe that we can also take 3 out. We will have 3 over 2. It will be P plus 3Q, right? So that is EF. So what is DE? Observe DE is the point from D to E. So we can do D goes to B, B goes to E. So DE is equal to DB plus BE, which is equal to P plus 3Q. Okay, which in terms of vector, it will be 1, 3 for the point DE. Okay, so coming back to here, DE will be 1, 3, and EF will be 3 over 2, and in terms of vector, that will be 1, 3 as well. So now we have to replace the information back in the equation. So what is EF? EF is 3 over 2, 1 over 3, 1, 3, equal to K. DE is 1, 3. So what is the value of K? We cross this one out. So K equal to 3 over 2. So that is your answer for part D.